Hello, boys and girls. Today we will see about the topic in the rotational dynamics, and topic name is conical pendulum. Topic name is conical pendulum. So before starting the meaning of conical pendulum and related problem, let us see what is meant by the pendulum. What is meant by the pendulum and then simple pendulum. Let us see first pendulum, then next simple pendulum, and then finally conical pendulum. Conical pendulum. So what is mean by pendulum? What is mean by pendulum? So to construct a pendulum, we need a rigid support. We need a rigid support. We need a rigid support, a string. A string may be or should be weightless, inextensible, such types of the character it must have. So the things which are needed to produce the pendulum are: the first is the rigid support, second is the string, and then teeny particle, teeny mass or teeny body, or it is called as other name like bob. It is a bob, means spherical body having very small size but having mass as compared large as compared to the size. So it is called as a bob. So when a body or bob is tied to a string, and supported by the support called as the rigid support, then it is called as the simple pendulum. Pendulum means this is the support, rigid support. This is the string. This is called as the string. This is called as the string, and this string is the weightless, then inextensible. So such types of the character it should possess. So string, and then to this end of the string a small teeny body, small teeny object or point mass are called as the bob. This bob is suspended by means of the string with the help of this rigid support. Then this arrangement is called as the pendulum. And then what is meant by the simple pendulum? When the bob is displaced this side and then release, then it is released. It will oscillate in a single vertical plane. Then such types of the arrangement is called as the simple pendulum. It is called as the simple pendulum. Then next is the conical pendulum. Then what do you mean by the conical pendulum? In pendulum, this bob or body, teeny object is moved in such a way that is allowed to move in such a way that the string, this is the string. First of all, displace it here at the position B. Then the bob is moved in the circular motion. Allow it to move in the circular motion, which is in the horizontal plane. Then what happened? The string will revolve along the surface of the conical or cone. This string will revolve along the surface of the cone. Suppose this is the cone, and this is the surface of the cone. This string, whenever revolve with this circular motion of the bob, the string will revolve along the surface of the cone, and the bob will perform the circular motion, which is the uniform circular motion. The bob will perform uniform circular motion. The such types of the figure or situation whenever we get when the bob is revolved in such a way that are allowed to move in the horizontal circular motion, then we get a situation like a cone. Situation like a cone. So such types of the pendulum are known as the conical pendulum. Such types of the situations whenever created are known as the conical pendulum. So let us see in the figure. This is the bob and this is the string. This is the string and this string has length L. Length of the string is L. But when the bob is performing uniform circular motion, the string will perform or show a cone. Show a cone, and at the point A, that means the rigid support. At the position A, there is a rigid support or support. This string makes an angle theta, with this vertical direction. With this vertical direction, the angle theta, it is called as semi-vertical angle. In this conical pendulum, angle theta is called as the semi-vertical angle. So bob is performing circular motion in the horizontal plane. So let us see, the bob is present at position B. Consider a situation at a certain instant, while performing the uniform circular motion in the conical pendulum, the bob is present at position B. Then this bob will experience two forces. So at position B, this is the bob, and bob will experience two forces, and these two forces are, first is the weight force mg acting vertically downward direction. This is the first force. And second force, that is the force T0, that means the tension in this string. And that tension is indicated by T0, and this T0 tension is nothing but a certain force, and this force always directed towards the position A. Directed towards the position A. So these are the two forces. First is the weight, second is the force indicated by T0 and directed this tension towards the position A. Now the first force and the second force. Now the force T0, that is the tension, we can resolve along the vertically upward direction and the horizontally directed towards the center of the circular motion. So we can resolve the T0, this force, along the vertically upward direction and along the horizontal direction. Suppose this is the vertically upward direction and this is the string, and the angle between these two will be same as that of theta, because these are the two parallel lines, and to these parallel lines, this line is intersecting with the same angles. So angle theta and angle theta will be same. So this is the direction or line which is adjacent side to this force. So along the adjacent side we get component, and that component will be T0 multiplied by cos theta. This is the first component. That means the effect along this direction of this force. So force is T0 directed towards the position A, but its effect along the vertically upward direction will be T0 cos theta. Then second component, which is perpendicular to the first. So second component will be always T0 sin theta. Now after finding out the components of the T0. Now see the figure and analyze it. Analyze it. In this figure, consider vertical direction. Vertical direction. There are two forces. First is the weight force acting downward, and second is the upward force, that means the T0 cos theta. Only these two forces are present here along the vertical direction. Both are opposite. But there is no motion along the vertical direction. Its other meaning is that the T0 cos theta exactly balances the weight force of the body, or weight force which is acting on the ball. So both cancels each other, means both balances each other. So, and second, along the horizontal direction, there is only one component. That is the T0 sin theta. This component, or this is the force, it is the one of the type of the force, or we can consider it as a force. This T0 sin theta force or component is directed towards the center, acting on the ball. This component is directed towards the center of the circular motion in this conical pendulum. So, and along the radius, directed towards the center. So this is the force which is acting on the bob, which is performing circular motion in the horizontal plane. So bob is performing circular motion, means there must be a required or necessary centripetal force, and that centripetal force is provided by the component T0 sin theta. So T0 sin theta, this is the component which behaves as centripetal force, and balances centrifugal force, which is directed outward direction. So this is the outward direction of the circular motion, that means the radially outward direction. And we know centrifugal force, it is always m r omega square. M means mass of the bob. R means radius of the circular motion, and omega means angular speed of the bob. If we know the mass, radius and angular speed, we can write the centrifugal force or centripetal force. Both forces, centripetal or centrifugal, always remain same in magnitude but oppositely directed. Centripetal force is directed towards the center, but centrifugal force is the outward direction, directed away from the center. So this is the centrifugal force, and T0 sin theta here in this circular motion balances the centrifugal force. Is it clear? Then write the two relations for this problem. Write the two relations related to horizontal direction and the vertical directions. So these two forces, force T0, are resolved into two components. First component is T0 cos theta, vertically upward direction. Second component T0 sin theta, directed towards the center. Now write the equations. So let's see, along the horizontal direction, T0 sin theta balances the centrifugal force, means m r omega square. So we can write here T0 sin theta, it is nothing but the centripetal force, and this centripetal force means T0 sin theta balances the centrifugal force m r omega square. Right here as equation number 1. Now along the vertical direction, the component T0 cos theta balances the weight, means T0 cos theta is equal to weight force, means mg. This is the equation number 2. Now equation 2 by equation 1 we get. So equation 2 means T cos theta. Equation 1 by equation 2. So let us clear. Equation 1 by equation 2 we get now. So equation 1 is T0 sin theta divided by T cos theta. T0 will get cancelled. We get sin theta upon cos theta. So at the left hand side, after dividing equation 1 by equation 2. At the left hand side we get sin theta upon cos theta. Now at the right hand side, mr omega square divided by mg, m will get cancelled. So remaining things at the numerator will be r omega square divided by g. So r omega square divided by g. So after dividing, we get sin theta upon cos theta is equal to r omega square upon g. So rearrange this equation and equate omega square. Equate omega square, we get omega square is equal to g sin theta upon r cos theta. So equate or rearrange this equation and equate omega square. We get omega square means g sin theta divided by r cos theta. Then next we know, but radius, this is the radius r. So we know the length of the string has length capital L. So consider this right angle triangle. In this right angle, the angle theta that we know, semi-vertical angle theta, this is the hypotenuse, and it has the value L. So as we know the angle theta and the hypotenuse L, so we can decide the value of front side of the angle theta, and the value of the front side will be nothing but, that is the radius. The value of radius r, it is nothing but the hypotenuse L multiplied by sin of theta. So radius will be from the right angle triangle, we can decide the value of radius from the information, that is the hypotenuse L and the angle theta. This is the front side. So for the front side, the value always equal to, that means r is equal to L sin theta. So place this value of the radius in this equation, and again in this circular motion, for one circular motion of the bob, it will take some certain time. The time taken by the bob to complete one circular motion, that time, definite time, is called as the periodic time. Suppose periodic time for the circular motion means one revolution is t. It is indicated by t. So r is the radius and r has the value L sin theta, and the periodic time is indicated by t. That means capital T is equal to period of uniform circular motion of the bob. So considering these two informations, we can write the equation for omega. We can reduce this equation in this form. That means taking the square root, omega square root is omega is equal to, but we know omega means always. Remember this equation for the angular speed, that means the omega, and omega means we know twice pi upon t. So omega, the basic relation for the omega is twice pi upon t, but we know omega means g sin theta upon r cos theta. Taking square root, it will be in the root form. Left hand side square root is omega, right hand side square root, left hand side square root is omega, but right hand side square root will be g sin theta under root of g sin theta divided by r means L sin theta. So instead of r, we have to write here L sin theta multiplied by cos theta. So sin theta will get cancelled. The remaining factors or equations can write in the next line. Omega is equal to under root of g, then L cos theta. So this is the next relation. So this is the relation for the angular speed of the bob. The bob is performing uniform circular motion. In that uniform circular motion, the bob has a angular speed as well as the linear speed. But in this case, we have derive the relation for the angular speed, and angular speed will be omega is equal to under root of g upon L cos theta. So this is the important relation. Then next, we know the periodic time or period of uniform circular motion. It is t. It is t, and t means capital T. It is always equal to t is equal to twice pi upon omega. T is equal to so while deciding the relation for the periodic time, use this relation. T is equal to twice pi upon omega. We know T is equal to twice pi divided by omega. We know omega under root of g upon L cos theta is reciprocal. 1 upon omega means reciprocal will be L cos theta upon g. So the periodic time can be written according to this relation or using this relation. The periodic time can be written twice pi, and then under root of L cos theta will be at numerator and c will be at the denominator. So t is equal to twice pi under root of L cos theta divided by c. This is the next relation. So these two relations are important. That means first is for the angular speed, and second, number 4 will be of periodic time. So both these relations are important. And lastly, the final relation we can derive for the frequency. So frequency of the bob in this circular motion means conical pendulum. The bob is performing circular motion, uniform circular motion with a certain frequency. The frequency means number of circular motions or revolutions per unit time. So number of revolutions performed by the bob per unit time, it is called as the frequency, and frequency is indicated by n, and it is always a reciprocal of the periodic time. So n is equal to 1 upon t. So placing the value of t here, we get finally n, that means the frequency n is equal to 1 upon twice pi under root of g upon L cos theta. This is the last equation number 5. So this is all about the conical pendulum. So next topic we will see next time. Thank you.